Well, I made a serious mess of the grill with that pizza. And there's
Well,
some tomatoes for James.
It's fancy. I'm going to make a serious mess of my fingers maybe when I'm eating.
I'm going to talk a little more about Green Planet. Just mention one thing, and James is going to talk about Cosmos. So I'm going to read a poem, and then I'm just going to mention one brief thing about the Green Planet that I'd forgotten to mention. So, and I watched the rest of it now. I watched it in its entirety, and
there was some interesting stuff on that.
For sure. I'm going to read my poem Late Summer Flies, which I wrote this morning, August 10th, 2024. I really hate late summer flies. They're patio picnic pests rounding around, so the food that you've made is soon food that they've found. They lick morsels of munchies you've made and lick every last piece, I'm afraid. You won't stop them, though every cook tries. I really hate late summer flies. It seems they're invincible, guys. They taunt you by making that horrible sound, buzzing right near your ear. If you swat, though they're bound to avoid you within their parade, making hell of your heavenly shade. Each one's torture, and none of them dies. I really hate late summer flies.
Yeah, they're amazing. They get worse, of course. November flies are just...
Well, they get smarter. It's the same ones.
Exactly right. All
they stay
the dumb
alive
ones have
and
been killed.
Exactly. Spring flies, well, they're really dumb.
Yeah, that's probably it.
Yeah.
And they probably learn. The stupid ones get killed, but the smarter ones learn, and boy, oh boy. Yeah. You know, what kind of helps is getting dogs that do not that are irritable, like Chihuahuas.
Yeah,
Because actually, when you've got them inside, the flies that survive go way up and they don't land on you that much.
Yeah. Opie's very good at catching flies.
Yeah.
And I'll tell him, Opie, you should catch that fly because you're really good at it. And he'll try. He's like, okay. And he'll really go all out trying to catch the fly.
Now, the one who gets annoyed by them is Elvis. He's got thick fur by comparison with Opie. Mm-hmm. But Opie seems to be more complacent about,
he's better at trying to catch him, yeah. Elvis is not as good
Well, he
at
starts
that,
snapping. He's not as big as Opie, so that's one of the problems. But I think both of them have kind of like they catch the really stupid ones. And I think the smarter ones are going, okay, I'm staying out of these guys' reach,
Okay, well, what I forgot to mention about this was maybe the coolest thing was about the fig tree bridges that people were making, and I can't remember what group of people it was who made this, but I guess they'd lay out the fig roots into split bamboo, and they'd put the bamboo back together, and the roots would keep growing, and they'd make bridges, living bridges
across fairly substantial rivers.
Yeah, pretty impressive. Yeah. And they'd keep weaving them and stuff, so they had rails and everything. It was just all alive. The bridges were alive. Very nice. So that's worth watching just for that.
A living bridge.
Really beautiful. And now I guess I'll put you over to James to talk about Cosmos.
Yeah, I was hoping to hit this pizza. I was hoping you'd talk a long time. But I'm going to leave the pizza a little bit later. And I've got a few things to say about Cosmos.
Well, if the flies start to go after it, I'll bring it inside.
I'm mainly worried about mosquito. Mosquitoes started buzz bombing. So. Not dive bombing yet. Anyway, let me get my notes here.
What I did with this pizza this time is I put the shrimp sauce, which doesn't have any shrimp in it, it's just to go with shrimp, as the pizza sauce base, and then I put the cottage cheese, which James found worked really nicely, and then the pesto basil power bowl, minus the chicken. And then James will put his own tomatoes on top.
Okay, so I'm going to go back to the Great Dying the other day, or later on. I started it today. I'm going to deal with, while it's hot, off the griddle, the thing, the two shows.
That you watched today.
Yeah. So one was about, started off with William Herschel and his son John Herschel. And they were kind of like on a beach.
Oh yes, I
stars.
remember that part. Yeah.
So, William Herschel was telling his son the stars are dead. You know, what does that say? Still see light. What is it? Anyway, they were saying, William Herschel was saying, might be true, the telescope and the time machine. So you're seeing through the at
That's
things
what they
that
say.
are really, really old.
Yeah.
So he knew that the faraway stars were away. So here's a kind of a scale. Moon is 1 light second away. This is what we've kind of found. Sun is 8 light minutes away. And Neptune is the average. It kind of has a orbit that's not like Venus's orbit. Venus' orbit is almost circular. Well, Neptune, sometimes it strays a little farther away from the sun, sometimes a little nearer, but 4 light hours away on average, about. And then, what is it, light year, 10 trillion kilometers away. Oh, a light year is about 10 trillion kilometers, approximately. The closest star is Proxima Centauri. So that's in the constellation Centaur, which I think you can only see, well, you can't see here, but we're not that far south. You see it better in the southern hemisphere. You might be able to see it at the equator. Anyway, that's 4, yeah, probably see it when you're on the equator. 4, or in the tropics, 4, even in the northern tropics, 4 light years away. About 4 years, yeah. So proxima means approximate, or more like proxima, like close. So that's, yeah. I was told when I was a kid, it's Alpha Centauri, which would be a big star, a very bright star, because and the reason why it's bright is it's not so much it's big, but it's just so close. But Proxima Centauri is even closer. Then the Pleiades are 400 light years away. Crab Nebula, which they figure blew up, I believe it's 1054, recorded by the AD, recorded by the Chinese. They figure it was a supernova. 6,500 light years away. 6,500 light years away. The Sombrero Galaxy, which is pretty amazing. It looks a bit like a sombrero. At least a sombrero that's reflected in water, maybe. 300 million light years away. So why is that so far away by comparison with the Crab Nebula? Well, it's a galaxy, so it's outside of the Milky Way, which is pretty well any star that we can see. We can see the Andromeda galaxy. Excuse me. I eat a lot of watermelon. It's kind of reacting with my stomach. Not too badly. It's just not an unpleasant feeling. Anyway, Andromeda galaxy. Some people can see that with the naked eye, but that's about it. Well, there are the large Magellanic Galaxy, and I'm going to bring that up a little bit later in this lecture if I've got enough time. A large Magellanic Cloud, I should say, and a small Magellanic Cloud. They're seen best in the southern hemisphere. I'm not sure if you can actually see that near the equator. Probably. Anyway, but there's a galaxy in the Coma cluster. That'd be Coma Berenices, I think. Berenices, however you mispronounce it. That's the hair of coma actually means hair. It can be, like from a different language. It means unconsciousness.
Are you comfortable there, or would you rather sit there?
I'm comfortable here. I think. Yeah, I found a way to sit.
Okay.
I have a different kind of back than pretty well anyone else, and I have to kind of sit sideways because my back's kind of curved. I got bone marrow cancer, and I've got 5 fractured vertebrae, compression fractures, and kind of all scrunched down. So my back doesn't sit the way it should, but I found a way to kind of live with it. I've been living with it for over 13 years now. They were giving me a year and a half to live originally. That's terminal, pretty sure. Anyway, the coma this one galaxy they mentioned, or Neil DeGrasse Tyson mentioned. Tyson, I always want to call it Tyson. Yes. 320 million light years away. That's a long ways away. If you want to go there, I'd advise you start out right about now. It's going to take you a while. And then, there's one. They were showing a red blob. And that was the kind of culmination of this process of working away from the moon to farther and farther away. 13.4 billion light years away. And I think he was saying the universe, starting from the Big Bang, which is creation. This is creationism of a different sort. A creationism that was invented by a prophet called Jules Lemaitre. So that's Julian, something like the master in French. And if you see any pictures of him, I advise you do. You'll generally see him with a weird collar. It's kind of like a white, straight collar all the way around, maybe. It was something like a priest, maybe even an abbé, but we'll say priest. Yeah, he was a Catholic. So it kind of makes sense. This is in the 20s, I think. They came up with this idea of the Big Bang. So it's before Hubble, I think it's 1929, came up with proof that Big Bang happened. Okay, so it's generally, that's when the Big Bang was born, 1929, but it was conceived, shall we say, by Jules Lemaitre. And was he a brilliant person? It's his own form of creation. Pretty sure he was saying, yeah, that's when God created the whole universe out of nothing. Well, I don't believe. I'm not a creationist. I'm just not. Yeah. So yeah, this red blob, I've read about these sorts of things. I've read about these red things. They say they're right on the edge of the known universe. They kind of like they're only, they date back to the beginning of the Big Bang. And of course, Neil deGrasse Tyson is saying, anywhere you're at, you flunkies way out there in this Sombrero galaxy 30 million light years away. You're in the center of the Big Bang. We're in the center of the Big Bang. Everyone's in the center of the Big Bang. Yeah, it's not really like a typical explosion, because it doesn't have a center. No. No. You're starting to deal with, you're dealing with creation, and then you're starting to deal with paradoxes and stuff like that. No. That's the kind of thing that you get with theology, like Catholic theology, Christian theology, whatever type of theology. You get all sorts of paradox, and you don't just live with them, you glory in them. That's what Niels Bohr did. He loved what he called complementarity. It's basically just paradoxes. Paradox after paradox. He loved that sort of spit. But maybe I'm using rhyming slang. I'll leave that up to you to judge. Anyway, what is happening with those blobs? They kind of look like the large Magellanic Cloud and the small Magellanic Cloud, which they figure are really close to us. They figure they're kind of like little allies, as it were, of our own Milky Way. They're the galaxies that are closest to us. We can actually see them with the naked eye. What's happening there? They are not big. They figure they haven't been gravitationally cohered, shall we say. And so, but then they see these blobs way out at the edge of the universe, near the edge of the universe, and they're blob-like. They're not like spiral galaxies or spherical galaxies. They're kind of like blobs, like the Magellanic Clouds would look like if they were a little bit farther away from us. What's happening there? I just laugh when I figure out what was happening. Wow, why would they be asymmetric and just blobs way out there on the edge? Because they'd be hard for us to see. Wouldn't they be huge and big? And of course, they're figuring out, I guess they're huge and they're big. And what's happening is we live in the Milky Way, which is one of the bigger galaxies out there that they've been able to sense. Not as big as they used to figure, but bigger than the average. Bigger than the average bear. No, bigger than the average galaxy. Yeah. Now, they've already discovered a solar wind, and I think they've discovered a galaxy wind coming from the center of the galaxy, from our Milky Way. Now, that's got to be powerful. You know what I'm saying? And powerful when it comes to galaxy winds coming from outside our galaxy. Wee little galaxy winds. Because most galaxies, by comparison with ours, the Milky Way, apparently are smaller. So they wouldn't have as powerful, you'd think, galaxy winds. Now, we're going to go back to Einstein. Einstein was a conservative. He was a fundamentalist. He harked back. He's supposed to be just like the cat's pajamas and the knees bees when it comes to cutting edge science. But he's figuring that space, vacuum of any sort, but particularly outer space out there, is just like a total vacuum. That's what he's figuring with when he's leading up to 1905, the big revolutionary, I don't know, it's 3 or 4 papers, I think it was 4 all told, that he published or got published in 1905. And so he's saying, he's saying light's been proven to be a wave by a guy called Thomas Young, and there are experiments to prove that it's a wave. And then we've got the fact that this is experience. Light is coming through outer space, and that's got to be a vacuum, so there's no medium to carry light as a wave through a vacuum, particularly outer space, which is thinner than any vacuum we can manufacture here on Earth, particularly back then, but even now. And so I get. And he's going, well, Newton had this idea in contradistinction to Newton's contemporary, Huygens, a Dutch guy, I believe. Huygens said, before Thomas Young, I guess he wasn't able to prove it sufficiently, he said it was a wave. So this would be around 1700. Thomas Young was around 1800. Almost exactly 1800 proves light is a wave. And Newton is going along saying, I'm a genius. Light is a particle. And then Einstein is an even greater genius, because he says light is both a particle and a wave, depends on what experiment you're laying down on. I'm going, hey, physicists, in the wake of Einstein, you refine your experiments, and you get it so it's one or the other. So I've seen the experiment from 1923 that's supposed to prove that light is a particle, because light coming around the sun is displaced, and it's by the sun's gravitational field. Eesh. You physicists should be scared, because you see how the stars are displaced coming around the eclipsed sun. I think it's 1923. Most of the stars, their light seems to be displaced towards the sun. But some are displaced kind of like parallel to the sun. Some are displaced towards the sun. Hey, physicists, what's happening there? Because the sun's gravitational field is not negative. Got that straight? And the displacement for the ones that are coming in, it varies. The sun's gravitational field is not that variable. Are you saying it is? Are you saying it's so variable that in places it's negative? Are you saying it's in places it displaces the light this way, kind of like parallel to tangent to the sun? Yeah, you stupid fools. What's happening is the atmosphere, as it were, is very thin coming off the sun. It's not really atmosphere. It's electromagnetic fields. Is so jumbled. It's moving the light from the stars, that some of it's from behind the sun, but light that's kind of scraping the edge of the sun, it's moving it around. Because you see, those electromagnetic fields, specifically the magnetic fields around the sun, are the medium for the light. There are magnetic fields throughout outer space. Okay? Space is full of them. This was predicted by a guy in 1937, a guy who's quite a late contemporary of Albert Einstein. This guy called Alfvén won a Nobel Prize. I believe it was 1971. Einstein died 1955. That's what I mean about a late contemporary. But Einstein's saying space is full of nothing. What a wonderful paradox, and Niels Bohr would just glory in that. Wow, complementarity. I love paradoxes, because when we get to the macrocosmic and the microcosmic, it's not like reality. Guess what? It is. It's like reality. It's not some wild and weird magical mystery tour going down into the atom and going way out into outer space and galaxies and stuff like that. It's not some sort of magical mystery tour that's being conducted by Ken Kesey, you know, like riding a big school bus or something like that, painted psychedelic sort of stuff. That guy was a nut bar, so was Niels Bohr. So was Albert Einstein. Nut bars. So Alfvén said, 1937, when we get out in outer space, we'll find it's full of electromagnetic fields. Not full of nothing, like Einstein pictured. And now Einstein was still alive, with 18 years to live. 20 years later, a couple of years after Einstein died, started sending Sputnik up in space, other sorts of things. Oh, Van Allen belts, I think, were discovered next year. Earth has a electromagnetic field way out. You know, not just sensed by compasses down here on Earth. And then they eventually found Earth had a tail extending away from the sun, like a compass, just not turned out. Not usually. There's something called a Gegenschein, where actually it's opposite from the sun. You're looking down the... people claim they say, and of course the scientists are saying, oh, wow, that's as good as the story of the flood. They actually see something that's 180 degrees removed at nighttime when it's when the sun is, let's say, in the you know, like noon position, way on the other side of the Earth. You can see in the midnight position on the ecliptic a little glow. Whoa, 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 that's good. It's there. It's called a Gegenschein. That's German for opposite shine, something like that. And people were actually seeing it. And you're looking down the Earth's tail. Check it out if you don't believe me. The Earth has a tail. It's just turned on very, very, very palely. Right? Yeah. Typical scientific sort of stuff. Oh, it's not there. And then now that they've discovered, oh, we knew it all along. We knew it all along. And they did. They were laughing at people who actually saw it. People who actually were perspicacious. Okay? I'll let you look up what that word in your funkin' wagnalls, your funky wagnalls. Anyway, yeah, it's so there actually is I got a nuclear physicist I'm not going to say where it came from because I don't want him to lose his job. I got him to do some other stuff for me. He kind of knew where I was leading with that one. He said, I could follow up what you're doing. This is up for about 45 minutes, but I lose my job. And all I said was, yep. Well, I said it like, yep. There's nothing more to be said. That's why usually when you say yep, there's nothing more. You close your mouth with that labial, the P. Yep, it's a stop. Yep. That's what it's called by linguists, a stop. You just stop. There's no need for any further conversation. Yep. That's what I said because I knew exactly what he was talking about. I know what the so-called scientific community is like and how it's been all the way along. You know, the scientific community way back in Copernicus' time, they were basically flunkies of the Catholic Church. Now they don't even have that excuse. They're just flunkies for the scientific establishment. And they're going along, you know, Neil deGrasse Tyson is saying, I encourage you young people to, you know, get out there and do your exploring. Yeah, if someone came up with something, like if he, I'm not a kid, but sometimes I think like a kid, you know. I kind of out there exploring stuff, even though I've turned 70. And he would be here pooping on my parade, peeing on it. Golden showering on my parade. No, it can't be this. No, it can't be that. Who are you, Neil deGrasse Tyson? You're a stupid flunky mouthpiece for this horrible, horrible scientific community. I started reading about Velikovsky and the way they pooped on their parade. They actually came out with Carl Sagan, all this sort of stuff. They figured after 1950, I had to get out there and do some propaganda. And Carl Sagan, Cosmos, that's a result of it. And Neil deGrasse Tyson, he met Carl Sagan. That's one of the great moments in his lifetime. 1975, the year Pauline was born. And, or maybe, I don't know. Yeah, Fats, I have. 1975, Fats met Carl Sagan, Ithaca, New York. That's where Cornell University is located. Anyway, so what's happening there? You see, with light, the way Einstein and everyone after it in the scientific community, so-called scientific community, has pictured it, has only one Doppler shift. Sound, we know, has two Doppler shifts. One having to do with the relative motion of the source and the receiver of the sound. But the other one has to do with you could have two source and receiver sitting totally still relative to each other, and the medium, if it's moving towards the source, then the sound is going to be the equivalent of red shifted, and if it's moving towards the receiver, it's going to be the equivalent of blue shifted. It's the equivalent. It's not the same thing, because what you get is a change of frequency, but there will just be a matter of not light or color, but how much time?
13 seconds.
13
Wrap her
seconds.
up.
So stay tuned, because what I'm going to tell you is there are two Doppler shifts for light, and with that